And once we get started, not right now necessarily, but once we get started, everybody make sure you're on mute unless you have something to say or ask. Sometimes what'll happen is somebody will have really bad feedback, and that's annoying. Or I've had it a few times where somebody doesn't realize they're on, they're not on mute, and they say some embarrassing things. So we don't want that for anybody. All right, let me see. We are recording. Okay, we've still got about 5 minutes. So maybe I'll just do some unimportant announcements or maybe reminders. This is stuff people should know anyway, right? So if they come in at 8 o'clock like they should and they miss these reminders, then it shouldn't be the end of the world. But let's see. The first reminder is your lab is technically due at midnight. Um, if you left and didn't work on it and haven't worked on it yet, please look at it as soon as you can. That way, if you need help, you can ask me. Because again, the due date is at midnight. So hopefully, if you need help, you'll let me know before the end of the business day so I can help you with the lab if you need it. And then for those of you who stayed in lab and showed me your lab, like I said on Wednesday, if I say something's wrong, but I told you it was okay in lab, remind me. So you look this over. So, just remind me. Except one person. One person, I think there was a mistake that I missed in person, but then when I checked the actual lab worksheet, it was wrong. But in that case, I kept it wrong and told them, "Hey, I know I missed this on Wednesday, and I'm sorry, but you'll need to correct this." Because again, it's not due until Wednesday. So if you've made mistakes, I mean, I said Wednesday. It's not due until tonight. So if you made mistakes, go ahead and make them. And just like the pre-labs, I handle the labs themselves the same way. So the due date again is tonight at midnight. But as long as it's done by the time I get around to grading it, I consider that on time. So that's the one announcement. What's some other announcements that everybody should know? So by Sunday, you should have 10 points of independent work. So yeah, go write your papers if you haven't. If you look at my online and look at your grades, every time you hit at the 10-point mark, then I post your independent work points to my online. So for example, if you have 24 points right now, and then you look at my online, it'll show that you have 20 points. But then once you hit 30 points, then I'll add the next 10 points. And not that it matters, but in case you're wondering why I do that, it's because, it's 10 points per week. So I add those per week. So again, using that example, if you have 20 points and you were to look at your grade online, you have 10 points for this week, and you already have your 10 points for next week. So any questions about independent work? I think most people have written a paper, which is good. You need to at least write one paper per week, even if it's a small one. Even if I said, like I said, just think of a question and answer it, or answer one of the questions that I posed to you. So we have a little less than 2 minutes. Do we have any questions? You guys are nice and easy. So we are pretty well ahead of the game. So today it'll be a double whammy. On one hand, I'm going to slow it down a lot, and on the other hand, we might not even have a full day of lecture since we're ahead, and since it's a Friday. And about a minute left. Let's see some other announcements / reminders. So again, even though we're not together, we can still do Red Friday. If you happen to be wearing red and want to get the extra credit points, and if you happen to support the troops and all that, then send your picture of you in red today. And just like I normally do, I'll post it to social media with your permission. So yeah, when you send the picture, if you allow me to post it, let me know. And if not, let me know. So yeah, if you're wearing red, you get a little extra credit. If you let me post it, you'll get a little bit more extra credit. And as usual, if then you share that, then you'll get even more extra credit. And then it is 8 o'clock. I'm going to wait until 8:01 because technically no one's late until 8:01. So again, are there any questions about anything before we get started? Okay, so somebody on Monday reminded me that the PowerPoint for chapter 2 was incorrect in the my online. I have fixed that this morning. It should be good now. And also that means that the other ones might be incorrect too. So I'm going to take a look at that once I'm caught up with grading and emails and things like that. Then I will go ahead and take a look and make adjustments. So always check back on and do what you did and let me know if there's any mistakes. But yeah, hopefully they'll be up to date because I'm not very, I shouldn't say just me, most faculty, what happens when we do an online course is there's employees who build the course for us, like build it like a website, and then we just run it, like kind of like using Facebook, right? None of you built the Facebook website, but you all know how to use it, right? That's like me with WVSU Online. I didn't build my little website, but I know how to run most of it. So because of that, like I said, this is a new course in that sense, and some mistakes will be out there and they will be fixed. And it is 8:01. Let's get started. The first word for attendance, and you guys are going to need to send me an email with these words at least, let's say 5 minutes. You need to send me this email within 5 minutes of the lecture being done with all the words in one email. And the first word will be storm, since it is storming outside. So are there any questions before we jump back into chapter 2? All right, let me present my screen and then open up the PowerPoint. And let's hope things don't mess up. I've noticed sometimes this thing will just randomly stop recording. So I will also randomly stop doing the lecture and back off and make sure that it's still recording. Anyway, slideshow. From current slide. Can someone please confirm that you can see the PowerPoint slide?
Yes, you can see it.
Okay, thank you. So this is where we left off. We were talking about functional groups. Well, actually, let me back up a step. I'll back up a few steps. What we're really talking about here is organic compounds, right? And you couldn't read this when I showed you on Wednesday, but we're learning about biological molecules / organic compounds. One of the first things that I told you about this that you need to know is that they are made out of carbon, right? We call them macromolecules, and I'm not necessarily going to ask you what an organic compound is or a macromolecule is, because that's what we're about to talk about. Then we talked about why these things are carbon based, and not that I'm going to ask you that, but the reason is because carbon is so versatile. It makes 4 bonds, which is a high number compared to the other stuff we talk about, like oxygen that does 2, or nitrogen that does 3, or hydrogen that does 1, right? So because of that, it can have a lot of different branching patterns. And that's basically where we left off. I also talked about the big 4, which we talked about previously in the chapter. So that's one of those things that you do need to know, like what are the big 4 elements, and you're going to be very familiar with them next week in lab, and they are carbon, hydrogen, oxygen, and nitrogen. And again, you're going to draw them so many times, they'll be probably stuck in your memory. Anyway, then we got here. Here's where we left off, if I remember correctly. And if I'm incorrect, someone tell me now. Didn't we end off with functional groups? You don't have to say yes, but if I'm wrong, speak now. Okay, thanks. You might be wondering why I don't know. It's because when you use a PowerPoint, as some of you might know, when you open that PowerPoint back up, there's a little thing that says start where you left off. So that's why I wanted to confirm. But anyway, yes, functional groups are these things that are attached to the carbon skeleton, and they have a great deal to do with the chemical properties of these molecules, right? How they react in chemical reactions, how they react with each other. And here's a table that's not from your textbook. You definitely don't need to memorize this. I'm not even going to ask you anything about hydroxyl groups or methyl groups or carbonyl groups or carboxyl groups. None of this. This is simply an example. And even without being chemist, you should be able to look at this and say, wow, look, these things are very different. Even just looking at the shape and size, those are very different. And if you've had chemistry before, especially if it was just a lower level chemistry, you might associate chemistry with math because it's a lot of equations. And that is true. But try to not think of it that way for this discussion. Try to think of this as literally 3-dimensional molecules fitting together and interacting together. So even just looking at these different shapes, you can see how they fit together differently and how they might fit into one thing, while this might fit into another. Excuse me, let me turn my pointer on. So that, yes, again, that is one of the reasons these functional groups change the chemical properties of these macromolecules. And that's just, again, just the structure. Then there's this other stuff which you have started to learn about. And again, you don't need to memorize this, but we know that polar molecules have slightly negative sides and slightly positive sides. So obviously those things are going to interact with each other because they're going to be attracted to each other. Because again, slightly negative, slightly positive. Not to mention ions, right? An ion that is fully positive or fully negative is going to interact with a polar molecule, but it's not going to interact with a non-polar molecule, right? So all these things. We'll talk about that later in the semester. So in a sense, this slide is very important because, again, the fact that these sides, functional groups, have these different structures and functions, that will be important later. But memorizing all this is very unimportant for right now. So are there any questions about this slide? Okay, moving forward. On the molecular scale, many biological molecules are gigantic, and that earns them the name macromolecules. There's no need to write that down. I'm not going to ask you what a macromolecule is. We're just going to learn about them. And there's no need to write down these three examples either. But the three categories of macromolecules we're going to talk about are carbs, proteins, and nucleic acids. And then on top of that, there's a fourth thing that we're going to talk about, which are lipids. But technically, lipids are not macromolecules, and I'll explain why when we get there. But for the exam, you do not need to differentiate. You don't need to, like, there won't be a test question where it says, which of these is not a macromolecule? Unless I do that for extra credit. But anyway, so yes, so technically what we're about to talk about are macromolecules. So that way, if you're reading about it, you know what the word means. But again, I'm not going to test you. You might look up, if you want for independent work, what are some other macromolecules? Now in biology, this is pretty much it. But obviously, chemistry has a lot more to do than biology. So you can see, are there other macromolecules that we do not discuss in this chapter? You could look that up for independent work if you want. So any questions about this slide before we move forward? All right. So here's some general concepts about macromolecules that you need to know before we dive into specifically the carbs and proteins and nucleic acids. This general theme among macromolecules is that they are all polymers, and you need to know what a polymer is. A polymer is basically just a bunch of monomers put together, and hopefully that makes sense to you if you know anything about prefixes, and you should by now. You know, poly means many, mono means one. So you stick a bunch of monomers together and you get a polymer. Some good non-biology examples of that would be a train, right? A train would be the polymer. A train car, like all the different cars that make up the train, that would be a monomer. A pearl necklace, right? A pearl necklace, the whole necklace would be the polymer. The monomer would be the individual pearls, right? So again, a polymer is made up of a bunch of repeating monomers. And generally speaking, especially in this course, the monomers are all the same. So when we have these discussions, there's no need to write this down yet because I'm going to tell you later in more detail. Carbohydrates, the polymers of carbohydrates are made up of single sugar molecules. That's actually what this represents, right? So this is a polymer of single sugar molecules, and they link up together to make the polymer. So that's going to be a common thing amongst these things that we're going to discuss in this chapter, other than lipids. Again, so because lipids technically are not macromolecules, but you definitely need to know for the exam, when we talk about carbs and we talk about lipids and we talk about carbs, proteins, and nucleic acids, that's a theme. There's going to be test questions on that. Like, what is the polymer of a protein? What is the monomer of a nucleic acid, right? You need to know those things. Another thing that you're going to see throughout the semester whenever we talk about chemistry, and oddly enough, we talk about it a lot. I mean, not like we do in this chapter, but it's there. But whenever we bring two monomers together to create a polymer, that is called a dehydration reaction. And the next slide will show you a good example of this. It'll be easy to remember when I show you. But yes, you need to know when you bring monomers together to form polymers, it's a dehydration reaction. As far as we're concerned, all the reactions, every single reaction that I teach you in this course is going to be, when you bring two things together, whatever they are, that is a dehydration reaction. So again, I don't know if you're taking notes, I would write down dehydration reaction, bringing together, right? The opposite is going to be breaking something apart. So when you're bringing something together, when you're building something, it's a dehydration reaction. And again, the next slide is going to make this make more sense. But before I go to the next slide, does anybody have any questions about this slide? All right, dehydration reaction. This we're bringing two smaller things together to build a bigger thing, right? So again, once you build something, that's a dehydration reaction, and this is why it's called a dehydration reaction. It's because this slightly negative part of this molecule is attracted to this slightly positive part of this molecule, so they come together. And then what you get when you put two hydrogens and an oxygen together, you get water. You don't even need to know those details. What you need to know for the exam is you need to know when any two things come together, when you're building a bigger molecule in this exam or in this course, it is called a dehydration reaction. That's one way you need to identify a dehydration reaction. The other way you need to identify a dehydration reaction is if you are forming water. You can think of it as if you squeezed water out of these monomers, right? And another thing in this, it'll be on another slide, but for now, if you have a chemical reaction, and it doesn't matter what's on there, X plus Y, whatever that is, right? Molecule X plus molecule Y gives you molecule Z and gives you water, Z plus H2O. You should identify that as a dehydration reaction. The reason you can identify this as a dehydration reaction is two things. We're building something, right? We brought two things together to make one thing. So that tells you it's a dehydration reaction. Additionally, we have water on the right side of the equation, right? Water is the product. Whenever water is the product, that is a dehydration reaction. And I know that sounds confusing because you're like, wait, when you produce water, that's dehydrating? And yeah, that can be confusing. But just try to remember that you're getting the water from the products, right? So we are taking water away from what we started with, and that's why it's a dehydration reaction. That in itself is probably not that confusing. But before we move forward, does anybody have any questions about dehydration reactions in general? All right. And honestly, there's only going to be a few questions about it on the exam. We're going to be talking a lot about different dehydration reactions throughout the semester. But the good news is, even if for some reason you mix dehydration reactions up with the other one, in a sense, it's not that important because it's just all about the names. But anyway, that being said, let's talk about the opposite of a dehydration reaction. And this is hydrolysis. So rather than bringing things together to build a new molecule, we are breaking down a bigger molecule, see, right down there, to make smaller molecules. That is a hydrolysis reaction. And in this case, instead of forming a water molecule, we're using a water molecule to break them up. You could almost think of trying to break up a train, right? You want to break this long chain of train cars into two trains. So you use a water cannon to bust them apart. But again, I shouldn't say again, opposite of a dehydration reaction. This time we have, molecule Y, and we use water to break it down. Sorry, this is really hard. I'm just using my mouse, or not my mouse, but the little pad on my computer. Anyway, water plus a larger molecule gives you two smaller molecules, right? So again, you should recognize that for the exam. If the water is on the left-hand side of the equation, it's a hydrolysis reaction. If you're breaking a big molecule down into smaller molecules, it's a hydrolysis reaction. So any questions about that? All right, the next word for attendance is fire, since that's the reason we can't meet today. All right, now backing up. Again, that's the general stuff you need to know about macromolecules, right? And macromolecules, again, are those polymers that are made up of repeating monomers. And when you bring the monomers together, that's a dehydration reaction. When you break them apart, when you break the polymers apart, that's a hydrolysis reaction. And again, the ones we just talked about include carbs, proteins, and nucleic acids. But like I said earlier, we're also going to discuss lipids. So this is it. This is the meat and potatoes of this portion of the chapter. You're going to need to know the differences between carbs, lipids, proteins, and nucleic acids. So you'll get a question where maybe I'll give you a monomer and you tell me which polymer it is. Or I'll give you the polymer and you tell me which monomer it is, or whatever the case may be. So again, a majority of the questions on the exam regarding these four these four biological molecules, you'll just need to differentiate between the two. So you know what I mean? Like it'll be more of you recognizing a carb. I give you an example and be like, oh yeah, that's a carb, not a protein, or that's a nucleic acid and not a lipid. That's going to be most of it. There will be some specific questions that you do need to know that I will ask about the four categories. But generally speaking, most of the questions will be about being able to differentiate between the four. And again, there's no reason to write these down because we are going to discuss them separately. Let me move forward. Let's see. We're going to talk about carbs. So technically, we should even start biological molecules until Monday. I don't mind getting ahead of the game, but I don't want to get really far ahead of the game. So let's call it a day for today, since we have the basic information about what we're going to talk about on Monday. When we come back on Monday, we'll talk about carbohydrates, and then we'll talk about lipids, and we'll talk about proteins and nucleic acids. And I'm not going to give the last word for attendance yet before I do, since we're early anyway, and I'm not holding you guys back from anything, like really early. It's only been 17 minutes. Does anybody have any questions about this chapter or anything else? Because again, this is getting recorded. So if you guys have questions about like how independent work works or how the grades work or how attendance works, does anybody have any questions? Please let me know. Now's the time to ask. All right. So then before I let you go, I'll remind you okay, I see somebody. Yeah, let me check my chat. Yes. I don't know. The best way, yes, if someone asks, is independent work due Sunday? Yes, it's due every Sunday. But the best way to think of it is you just need to be doing it basically constantly. I wouldn't hold off on and do it every Sunday. Like I would just do it when you think of it. Technically, it's due every Sunday. Technically, you need 10 points every week. And technically, in 10 weeks, you need 100 points. And your grade will reflect it. So, if you haven't done anything in 2 weeks, then obviously you're going to have 2 zeros. And that's going to really bring your grade down when you look at your grade for that day. However, if you, for some weird reason, and this never works, I swear, never once has anybody been able to pull this off. But if you wait until like the week 10 and try to get your 100 points on that on that last weekend, I'll allow it. But I don't recommend it. So yes, it is due. Oh, and on the flip side, or on a similar note, let's say you finish this week with 9 points, right? So I go into WVSU Online. I put 9 points in for this week's independent work score. Then we move on to next week, right? So then let's say next week on Monday, you write a paper and get 1 point. So I'm going to take that 1 point and I'm going to apply it to the past week since you only had 9 points. I hope that makes sense. So yes, you have 10 points per week, but your points are going to go, I'm going to add them 1 week after the other. So you know what I mean? You're never going to have a 9 for 1 week and then an 8 for another week and then a 10 for another week, right? I'm going to add your points. They're going to be back added, so to speak. Until you hit 10 points, I'm not going to add any more points to the next week. Hope that makes sense. Another good question. Colin asks, no, don't use the same document you've already sent me. I mean, do it the same way, right? Use Google Docs. Share that document with me, but there should be a different document for each paper you write. And that sounds picky, but it's for a good reason. It helps keep things organized, and it's easier to look things up and check things. Good question. Any other questions? All right. Don't forget to use your sources in independent work. Don't forget to send me those red pictures if you want to. And I will see you Monday, but the last word for attendance, let's just say soccer is the last word for attendance. So you guys have 5 minutes. So send those words to me before 8:25. Otherwise, you'll have to watch a video and answer the questions. So have a good day. Have a good weekend. And I will be online for office hours.